Before we start graphing our polynomial functions, we would like to discuss something called the end behavior of polynomial functions. The end behavior of a polynomial function is describing how the graph of a polynomial eventually behaves. And it's all dependent upon the leading term. Now to determine the end behavior of a graph, all we have to do is look at the leading term. Now let me give you how the end behavior is described according to the leading term. So watch this. If the polynomial function has even degree, so if it's degree 2, degree 4, degree 6, and so forth, with a positive leading coefficient, that means the graph eventually behaves like this. That means eventually the graph goes up forever on the left, and it goes up forever eventually on the right. Now there might be some things that happen in between the graph, in between these two branches. There's some intercepts and things like that, but eventually the graph goes up forever on the left, forever on the right. Let me give you proper mathematical notation for this end behavior. This says as x approaches, that arrow means approaches, as x approaches negative infinity, that means your x values are getting smaller and smaller and smaller. F of x approaches positive infinity. So as you go to the left, right, because when x values get small, that means you're going to the left. So as you go to the left, eventually your y values keep on getting higher, larger and larger and larger to positive infinity. So this notation describes this end behavior. As x values get infinitely large, this says as x approaches infinity, that means x values are getting larger. When x values get larger, that means you're moving to the right. This says f of x, or y values, are also getting infinitely large. F of x approaches infinity, so that means it's going up forever. This notation is the mathematical notation for this end behavior. The next case is when the function is even degree but with a negative leading coefficient. If the leading coefficient is negative, then the end behavior is like this, where it's down on both sides. Remember, there's a lot of stuff going on in the middle, maybe some intercepts and things like that, but eventually the graph goes down forever on both sides. Here's the mathematical notation for that. So we write as x approaches negative infinity, that means as you let your x values get smaller and smaller and smaller forever to the left, the graph goes, f of x approaches negative infinity. Okay, and then as x approaches positive infinity, so as x values get larger and larger, your f of x values approach negative infinity. All right, let's go to the next case. Now we go to where the degree of the function is odd with the positive leading coefficient. The end behavior is up forever on the right and then down forever on the left. Once again, there's things happening in the middle, right? Intercepts and so forth. The mathematical notation is as follows. As x values get infinitely small, so as x values approach negative infinity, f of x approaches negative infinity. As x values approach positive infinity, f of x approaches positive infinity. Okay? So this here says as you go to the left forever, the graph goes down forever. As you go toward the right, the graph will eventually go up forever. All right, case 4 is the last case. This last case is also odd degree, but a negative leading coefficient, and that would give you this end behavior in your graph. And one last time, there's a lot of things happening in the middle, some intercepts and things like that. Here's the mathematical notation for the following. As x values approach negative infinity, f of x approaches positive infinity. As x values approach positive infinity, f of x approaches negative infinity. In words, this would say, as your x values get smaller and smaller and smaller, the graph will eventually go up forever. As your x values get larger and larger and larger, your graph eventually goes down forever.